Hey, I'm Yoni Shternhell, technologist at Sandisk Standards Group. In this video, I will discuss the NVMe Express Power Limit Config feature, including its use cases and applications. NVMe Power Limit Config is a new feature introduced by NVMe Express, and its goal is to give the host more precise control over an NVMe device's power consumption. Traditionally, NVMe devices exposes a fixed set of power states, each with a maximum power draw. While that works well once the operating system is up and running, it can fall short during early boot stages, like BIOS, where power availability is more constrained and predictable behavior is critical. The primary goal of the Power Limit Config feature is to allow the host to enforce a strict power cap on the device, regardless of the device's advertised power states. Once that cap is applied, the device restructures its behavior to ensure it never exceeds the defined limit, at least until the device is being explicitly directed otherwise. This gives platform designers confidence that the storage power consumption will stay within budget from the very first moment the power system power on. NVMe Power Limit Config enhances the existing benefits of NVMe technology by building on its already strong performance and efficiency to add more precise and transparency to power management. One key enhancement is the introduction of a new field that indicates the maximum achievable bandwidth for each power state. This means hosts can now understand not just how much power a state consumes, but also what level of performance to expect from it. That visibility makes it much easier to evaluate real-world trade-offs between throughput and efficiency. Power Limit Config also allows the host to set power levels between advertised states, enabling finer control and more optimized system behavior without disrupting existing NVMe functionality. One of the biggest challenges NVMe Power Limit Config solves is predictable behavior during early boot. At the early boot stage, the operating system isn't available to manage power transitions. Yet, the platform still needs to ensure that no component exceeds available power. Relying solely on standard NVMe power state can be inefficient or insufficient in those scenarios. Power Limit Config also addresses gaps where platforms need high-resolution power control than what's natively advertised by the device. Even if an SSD supports higher power levels, the host can downcap it to match system constraints. This results in more predictable performance scaling, tighter alignment with platform budgets, and smoother interactions between the host and the NVMe device across all operating conditions. Some of the ideal use cases for NVMe Power Limit Config include client platforms, especially laptops. During early boot, a laptop needs to ensure that every component stays within a very tight power budget, and Power Limit Config makes that possible right from power on. It's also extremely useful when battery levels are critically low. Instead of relying on complex power state transitions, the system can temporarily cap SSD power consumption to conserve energy. Thin and light notebooks and other component systems benefit from Power Limit Config as well, since they operate within strict thermal and electrical limits. Power Limit Config prevents NVMe devices from drawing more power than the platform can safely supply, helping maintain stability and efficiency. To learn more, I recommend checking out my recent blog post covering the NVMe Power Limit Config feature on the NVMe Express website. You can also explore the full set of NVMe specifications on our website at nvmeexpress.org.